I just helped this young student pilot to calculate both heading and ground speed using a crp5 and a free Aviator app, and what she did was simply taking advantage of the blueprint that I'm going to be sharing with you in this video. In this video, I am going to break down everything that we did and share with you exactly how you can do it too. But I will warn you, if you skip just one part of this video, it's going to be the reason that this method doesn't work for you, and it's going to be the reason that ultimately you failed to pass your theory exams for the first time. First and foremost, let's write down the figures we have been given on our practicing example question. On this question 1, we have been given true course as 120 degrees, true airspeed as 120 knots, wind direction of 150 degrees, and finally wind velocity of 12 knots. Now the question is, what is our true heading? With our crp5, let's wheel the wind direction at the true index. Second, slide the card and place the Gromate at the value of the true airspeed, which is 120 knots. Next, count the wind speed upwards from the true airspeed, then put a mark on it. This will be 12 units from the true airspeed in the upwards direction. After marking it, rotate the wheel and put our true course angle of 120 degrees at the true index. Slide the card to a point where the marked point should be horizontally in line with where the value of the true airspeed was initially at. Where the Gromate is, that is our ground speed. In order to identify the heading, first point out if the marked point is to the left side or to the right side. If it's to the left side, count the number of units from the longitudinal axis towards our marked point. After counting the number of units, subtract the number of units from our given track. The value that you will get, that will be our heading. However, on this example question, our marking is towards our right side. So we will count the number of units from the longitudinal axis towards our marked point. Our number of units is 3 and it's towards our right side. Therefore, to get the true heading, it will be true course plus the 3 units to our right. The value that you will get, that will be our heading. On our second question, we have been given true course as 255 degrees, true airspeed as 100 knots, wind direction of 200 degrees, and finally wind velocity of 10 knots. Now the question is, what is our true heading? With our crp5, let's wheel the wind direction at the true index. Second, slide the card and place the Gromate at the value of the true airspeed, which is 100 knots. Next, count the wind speed upwards from the true airspeed, then put a mark on it. This will be 10 units from the true airspeed in the upwards direction. After marking it, rotate the wheel and put our true course angle of 255 degrees at the true index. Slide the card to a point where the marked point should be horizontally in line with where the value of the true airspeed was initially at. Where the Gromate is, that is our ground speed. In order to identify the heading, first point out if the marked point is to the left side or to the right side. If it's to the right side, count the number of units from the longitudinal axis towards our marked point. After counting the number of units, add the number of units from our given track. The value that you will get, that will be our heading. However, on this example question, our marking is towards our left side. So we will count the number of units from the longitudinal axis towards our marked point. Our number of units is 5, and it's towards our left side. Therefore, to get the true heading, it will be true course minus the 5 units to our right. The value that you will get, that will be our heading. In order to confirm our answer, I will give you our recently created Aviator app, of which we can use it to confirm if our values are the same. But before we confirm with our app, let's challenge ourselves. If the app outputs our crp5 heading, we should click the like button on this video. And if it outputs our crp5 ground speed, we should click on the subscribe button as fast as our ground speed is. Without further ado, let the challenge begin. On your computer, click on the first link in description. It will direct you to our website, of which it's where we will be able to download our Aviator app. To download the software, just click here, or you can click on the Download Now button. By clicking, our program will start to download immediately. After the download is completed, we will be required to paste our zip file on a new separate folder. With the downloaded zip file, we are required to extract it by clicking Extract here. After extracting the zip file, this is how it will look like. Open the folder, and within the folder, you should double-click the calculator for heading and ground speed. Once the software opens, it's now time we identify what our question requires us to solve. On our first question, we have been given true course as 255 degrees, true airspeed as 100 knots, wind direction of 200 degrees, and finally wind velocity of 10 knots. Now the question is, what is our true heading? We will type in our wind direction, which is 200 degrees, our wind velocity, which is 10 knots, our true airspeed, which is 100 knots, and finally our true course, which is 255 degrees. After entering the correct details, you should click on Calculate. Immediately, our program will output to us both our true heading and ground speed. As we can see, the application program shows exact same results as our crp5 method. On to our second question. We have been given true course as 120 degrees, true airspeed as 120 knots, wind direction of 150 degrees, and finally wind velocity of 12 knots. Now the question is, what is our true heading? We will type in our wind direction, which is 150 degree, our wind velocity, which is 12 knots, our true airspeed, which is 120 knots, and finally our true course, which is 120 degrees. After entering the correct details, you should click on Calculate. Once again, our program will output to us both our true heading and ground speed. As we can see, the application program shows exact same results as our crp5 method. I best believe we have accomplished our challenge, so kindly fulfill your promise by clicking both the like and subscribe button. Now that we have covered how to calculate both heading and ground speed, you should probably watch this video next, because you will learn a more quicker way on how to find track and ground speed.